Welcome to Building Sustainability, the podcast that brings you interviews with designers, builders, makers, dreamers and doers, exploring the wide world of sustainability in the built environment by talking to wonderful people who are doing excellent things. I'm your host, Jeffrey Hart. So it is April in 2020, and this month we'll be releasing 3 episodes. The reasons for that are threefold. Firstly, coronavirus. I'm sure you've heard of it. With everyone being at home, it seems right to do my best to send out more content, try and keep people entertained. With everyone being at home, it's made the task of scheduling and recording conversations actually quite a lot easier. So I am racking up quite a few conversations with people in their homes. I just want to get those out and shared with people. I think maybe a more sensible option would be to bank all these conversations so I have less work to do later. But that feels a little bit like hoarding toilet paper. And I think more good will come from just pushing out more episodes. Second reason is that it's actually the Building Sustainability podcast's first birthday. We have been going for 1 whole year. So this is kind of a celebration, giving you some extras. But also, I promised an episode a month. And there's been a couple of months that I missed. So this is sort of making up for it. So there you go, 3 episodes this month. The more eagle-eyed of you may have noticed that we've got a new logo that was designed by the wonderful Lee John Phillips. If you don't know his work, you should check out his Instagram, which is Lee John Phillips. I'll put a link in the show notes. He is maybe best known for his shed project, where he is going through the contents of his grandfather's shed and drawing each and every item in exquisite and very, very beautiful detail. So that's every nail, every bolt, beautiful, beautiful hand tools, sort of trinkets and little scraps in his most exquisite style. And I'll talk a little more at the end of the podcast about the logo, but I just wanted to say a big thanks to Lee John Phillips. In this month's episode, I am talking to Lucy Pedler. Lucy is an architect with 34 years of professional experience in the UK and in the US, and has particular expertise in sustainable building practices. Lucy created the Green Register in 2000 as part of her lifelong commitment to the promotion of sustainable building. So we talk about retrofitting existing buildings. Now, retrofitting maybe isn't a term that you're familiar with. My definition would be that it's refurbishing a house, but bringing the building's efficiency up to modern building standards, as well as the looks and the feel. This focuses mainly on the 3 areas of stopping heat loss, creating air tightness, and managing moisture. In this conversation, we talk a little bit about Lucy retrofitting her own home. We talk some about internal and external wall insulations and the difficulties of either. And we touch a little bit on passive house, which is really the extreme end of retrofit, where you're really tightening up the building, lots and lots of insulation, very airtight, and controlling the conditions in the house. So that's it from me for now. I should say that these are recordings that are done from Lucy's own home and me in mine. So there are some background noises. I think everyone's becoming pretty accustomed to maybe a little DIY home broadcasting at the moment, with doctors and politicians all talking over video conference. So perhaps it's not as jarring. but yeah, the sound quality is slightly diminished, and you might hear the clinking of cups or sirens in the background. I'll be back at the end to do a quick roundup, and I'll also talk a little bit more about the logo design with Lee John Phillips. Enjoy the episode.
I trained as an architect, qualified back in the dark ages of the mid-80s, and worked in the conventional sense for a while, but realised that sort of the traditional form of architectural service wasn't really for me, and I was always interested in the environment. Mm-hmm. Spent a long time trying to marry those two, and got the opportunity to work at the UK's first green building store in London.
Okay.
And so I kind of took a lateral step in my profession and was learning about natural building materials and sustainable building practices in general. And I did that for 5 years. I created their seminar program. Mm-hmm. And then I realized I missed architecture. So in 1999, I sort of started my own architectural business. But one of the most profound things that I discovered working at this building centre was the lack of independent advice and guidance on sustainable building. Lots of manufacturers will give lots of very useful technical information, but it's naturally going to be biased towards their products.
Sure. Yeah.
And the seminar program, it was called Construction Resources, which sadly is no longer. The seminar program I was working on there was an absolute appetite for independent information about sustainable building. So at the same time as starting my own small architectural business, I created the Green Register.
And so what's the Green Register's aims and objectives?
So it's now 20 years old, and we had 3 aims, the first of which is to provide independent information that was unbiased. The second was to provide opportunities for networking. So if you kind of think 20 years ago, if you talked about sustainable building, you were looked at a bit odd, and it was very sort of alternative and brown rice and lentils kind of stuff. And those of us who wanted to do this really needed to sort of meet other like-minded people to reassure us that this was not mad and this was quite a sensible way of going. And the third aim of the Green Register was to provide a register of professionals for clients who wanted to find people who were willing to do this kind of work. Again, going back to working in construction resources, we get a lot of clients coming in, looking around, liking what they could see. There were full-size mock-ups of sustainable building practices. They go back out the door, they couldn't find anybody to deliver it. Mm-hmm. So we wanted to create a register of people who were keen, who were committed, and clients could go to architects, engineers, builders, and so on. And that was the idea of that, was that they could then find somebody who wasn't resistant to these ideas.
So how many people do you have on the register?
So we have several hundred. One of my colleagues has the exact numbers. They are, there is a prerequisite to join the Green Register, which slightly limits the number of people on it, in as much as we don't just want somebody to pay a fee and then join us. So we have a kind of way of filtering out people, and they have to attend a certain minimum number of hours of Green Register training.
Okay.
And so we train tens of thousands of people over the years, but the actual number of members is a few hundred.
Okay. And then you've mentioned training. I was having a look at your website earlier. You've got lots and lots of training opportunities going on in a whole variety of topics.
Yeah, well, I think as an architect, when I was working in sort of conventional architecture, we used to be the lead consultant, but we would work with all the other players in the construction industry, and it was very much a team effort. So when I started the Green Register, I really didn't want this just to be a training provider for architects or engineers. So there's a lot of our events are applicable or appropriate for multiple disciplines. And we actively encourage cross-disciplinary discussion. So if we get a room full of architects and engineers and some builders and maybe some planners, we allow a lot of discussion in the events because it's really important for everybody to hear their other people's perspectives.
Yeah.
And so the training is designed, to attract a multidisciplinary audience, but also to look at all aspects of sustainability. So a lot of focus is quite rightly made on energy, but there's all sorts of other things to do with sustainability: water, health, well-being, material use, reduction in waste. And so we try to cover as many of those topics.
Well, I think you've done an excellent job. And I think that the combining of the disciplines is really beneficial. I think there's a lot of times when, as a builder, I get drawings from an architect that don't quite make sense in the real world, and that's the sort of frustration I feel sometimes towards architects, and I'm sure there's many that come in the other direction. So getting everyone in the same room to actually kind of talk about why they're feeling like that, what their troubles can be, is really beneficial.
I so strongly believe that. Unfortunately, we have a slightly adversarial situation in the UK. My husband's American. We used to work in the States, and it's a much more collaborative approach between the professions and contractors there. And I kind of really enjoyed that way of working. I mean, the particular practice I was working at in Boston, we'd often get the builder right at the beginning, and they would inform some of the detailed drawings that we would do. And here, unfortunately, builders complain that architects don't know how to build buildings, and architects complain that builders don't do good quality work. Neither of which is true, but it's a myth. It's myths that are perpetuated, and it doesn't really get us anywhere. Yeah,
certainly. The amount of times I've heard recently about buildings being designed, and then by the time it gets to the builder and the builder actually puts a cost on it, it's then out of the budget of actually the client, and has to go back to the architect and get redesigned. And so, yes, that's something we've done in Hartwin, is try to be present from the very beginning.
It's a joyful way of working, actually. And this sounds a bit defensive for architects, and I kind of think it is, but we've been demoted in our status. So we're often the contractor's, subcontractor, if you like. So we have much less influence on the way things are built. So we have to kind of front load a lot of our stuff at the beginning. So I think the procurement processes have not helped this, particularly when you're trying to build a sustainable building.
So one of the events that I attended was the Green Register Hot Topic just recently in Bristol, or just before Christmas, actually. That was focused on retrofit. Now, for the listeners who might not have heard of that, what is retrofit?
So we have an annual conference every year, and it's called the Hot Topic. And as you say, the last one was on retrofit. Different people have different definitions of that. My definition of that would be renovation, sustainable renovation, really. I mean, people use refurbishment, renovation, retrofits come on the scene as a term more recently. And generally, I would understand it to meaning renovation using sustainable principles. So looking at a building, trying to improve it, but improving it with the environment in mind.
Okay. And what sort of improvements would you be looking to make? So
we're working on a project called Future Proof, which I think we may talk about later, but that's dealing with the domestic market, so housing. And we absolutely start with a whole house approach. So whatever you do to improve a house, it has to be looking at it holistically. And we try to encourage people to look at fabric first. So we're looking at the walls, the floors, and the roof, and trying to improve the insulation levels of that, bearing in mind moisture movement and the fact that you might have unintended consequences as a result of adding insulation, making the building more airtight, but then you have to have a ventilation strategy. All these things are interrelated, but we do start with a whole house approach, and we start with fabric first. And then if there's any more budget left, then we look at the kind of renewable energy options like solar panels.
Okay. So thinking about our current housing stock, what sort of insulation levels would there be in a sort of standard home, maybe a Victorian house? Or...
So it does very much depend on the period of the house. Post 30s, a lot of them have cavity walls, so the walls may already have some level of insulation. Mm-hmm. Most houses have a pitched roof, and it's extraordinary how we don't yet have all the houses with loft insulation. Or inadequate amount of insulation. And that is an incredibly low cost, high carbon saving measure. Yeah. So I would look at that as the very first thing, is try and improve the loft insulation. As I say, you can almost do it yourself if you protect against lack of ventilation in the roof space. That's a detail we talk about with our delegates. And then once you've looked at the loft insulation, you might look at things like wall insulation, which is complicated for pre-1920 houses because they're generally solid wall houses. And a lot of those are what might be referred to as high values. So they're decoratively very beautiful on the outside. They might be in a conservation area. There might be limitations on what you can do to the outside. Mm-hmm. So you then start looking at internal wall insulation, and it's very, very important when you're looking at internal insulation to do it properly. And then there's floor insulation as well, which, depending whether it's suspended timber or concrete, have different solutions.
If we're talking about putting insulation inside the walls, so we have two options. Is that right? There's internal or external.
That's right. Yeah.
And is there one that's preferred?
External wall insulation is far better for a number of reasons. It avoids some of the detailing issues that you get with internal walls hitting external walls when you're doing internal wall insulation. You're not losing floor space by doing external wall. You're also putting a big tea cosy over the house, so you're taking advantage of what's called thermal mass, which is the brick or the block or the stone of the building to hold on to the heat. Mm-hmm. And it's a much more effective way of doing it. If you do have aesthetic issues, though, that might not be possible. Yeah. It's more expensive per square metre than internal wall insulation. And you have to think about the weather, which you don't have to with internal wall insulation. But there's more risks with internal wall insulation.
Okay. So what are some of those risks?
The main risk with internal wall insulation is you're applying a layer of insulation on the inside, which moves something called the dew point. It's the point at which airborne moisture, which is generated in the house through cooking and showering and so on, and that dew point gets moved behind the insulation. And you may well get what's called interstitial condensation, which is droplets of moisture behind the insulation. Now, if that insulation is a synthetic insulant, it gets trapped. The moisture gets trapped. And we've seen numerous schemes where the internal wall insulation had to be taken off because of mould problems, and there's black mould behind the internal wall insulation. Whereas if you use a natural insulant, wood fibre is a really good example. It can usually cope with that moisture. I say usually because you have to have a ventilation strategy alongside it. But we at the Green Register strongly advise using a natural insulant for internal wall insulation.
Great. And that's wood fibre you've just mentioned. What is that product?
So it is actually usually virgin wood rather than recycled wood, pulping it and then heating it up, and the natural resins bind the fibres together. So in terms of a sustainable building material, it's a pretty good product. Yeah. It's generally not using high value timber. There's not a huge amount of energy going into making. Obviously, you have to heat up the fibres. But in terms of health and well-being, there's very little added to a wood fibre board that would be detrimental to the environment.
Excellent.
And it's really breathable. It's excellent in terms of its moisture management. Yeah.
When you say breathable, can you elaborate on that term?
Yeah, it's a bit of a rubbish word, actually. And people have tried to do enhanced moisture vapor transfer and all sorts of other
that's
equally useless, not useless, but difficult. It's basically saying that if a material is breathable, it's not just vapor permeable. Like a mineral wool insulation is vapor permeable. It will allow airborne moisture to travel through. But a breathable material actually can hold on to the moisture within the fibres of the insulant, in this case, if we're talking about insulation. So it's kind of like a reservoir, and it's able to manage moisture much more safely than a synthetic insulant. And the reason why breathable is used is that you can absorb that moisture, but the principle is you can then release the moisture to the outside. So it doesn't stay in the material, it moves out.
Okay.
Yeah.
So using it as a sort of battery almost, as a sort of rechargeable.
It's a good way to put it, yeah.
Excellent. And then going back to external insulation, I'm just, hopping around quite a lot with my brain. It seems like if that's the preferred option, it seems like there's also difficulties there, which... just sort of coming into my mind instantly as if you put a big chunk of insulation on the outside of a building, what then happens to the eaves? Do you then have to build an extra bit of roof?
Yeah, it's a really good question. There was, you'll have heard of the Green Deal, which was a now defunct government scheme that was trying to deal with the issue of people who wanted to improve their houses but didn't have the capital costs up front. Yeah. And so the government loaned them the money. And there was a scheme in Preston where they did a lot of external wall insulation. And there was a rush for this government funding, very little training, very little understanding about moisture movement and so on. And the external wall insulation that was put on these houses had to be removed. It was so badly done.
Right.
And one of the reasons was exactly what you're identifying, which is that they'd put the external wall insulation on. This was a group of terraced houses, and they literally just stopped it at the eaves and just capped it with an aluminium capping. Yeah. And what happened over time is that the rain or the moisture went behind the insulation, got trapped, increased the moisture levels in the wall, and residents who'd never had mould in their houses started to get mould growth in their houses. So neither external or internal wall insulation is a breeze. It has to be done carefully. Yeah. In Bristol, there's a very good guide that Bristol City Council created called the Bristolians Guide to Solid Wall Insulation. It's freely available on their website, and it talks about a lot of the detailing. For example, you can put a little extension ladder on the end of the eaves to make the eaves longer, so that when you put the external insulation, it's covered up by the roof.
Right.
We put external insulation on our house, but we're A, detached, so we've got no issues with boundary conditions. B, we had a big overhang, so the eaves was about 300 or 400, and it could take that extra thickness. But you're very right to identify that you have to think about those details really well. You have to take the rainwater goods off. I've seen examples of external wall insulation where they just cut around the downpipe.
Really?
Yeah. And I think the concept was, oh well, there's insulation on most of the wall, surely that's okay.
Yeah, better than nothing.
But actually what happens is those little gaps concentrate all the heat and moisture transfer and make unintended consequences.
Right. And what could be those unintended consequences?
Localized thermal bridging, localized moisture ingress, damp, mold. Usually not, if it's brick, it's not deterioration of the fabric, but of course if it was timber frame, it might actually be threatening to the actual structure of the building, because timber's not very good above about 22% moisture content. Yeah. So it really has to be done carefully. In the Green Register, we run loads of courses on this to try and avoid the worst detailing.
Yeah. So you said a term there, which again, some people might not be familiar with, which was thermal bridging.
So thermal bridging is where there is an element in the wall, the floor, or the roof, which is going from inside to outside without a break. So if you imagine, for example, over a window, you get those kind of catnic lintels, seal lintels, which have a flange that goes above the window at the bottom of the brick and the block leaf, and then a triangular piece in the cavity. Well, that's actually providing a continuous link from inside to outside. So what that does is any heat from the inside can travel along that steel. Equally, the cold can travel inside. It depends on the temperature differential. And when you've got that kind of localized temperature difference, that attracts moisture.
Right.
Because nature's always trying to balance things out, whether it's temperature or difference in relative humidity. Nature's always trying to balance things out. So if you've got a route where you've got a heat differential and you've got a piece of material that's going from inside to outside, that's going to make a problem. And that's called a thermal bridge, anywhere where there's a direct connection between inside and outside. Okay.
So does that mean, I'm asking a question like I have no idea of the answer. So that must mean that you will need to have continuous insulation the whole way around your building then?
Absolutely. Windows is a classic example. So when we put our external wall insulation, we were lucky enough to be able to take out the windows. They were the old Crittall type. They'd been there since the building was built in the 30s, and you could see daylight between the frame and the wall. They were practically pointless. And when you take the windows out, you need to return the insulation to the reveals of the window.
Yeah.
Whether it's internal or external, you have to have some kind of overlap. What tends to happen if you're not replacing the windows is that the insulation will run into the reveals, or it'll just stop at the reveals, in which case you have a thermal bridge. You have this gap where you can get cold or heat transferring, and then you get the localized moisture problems. And the advice is to always overlap your window with your insulation.
Okay.
So when you're looking at a section through a wall, the insulation in the window should have some overlap, even if it's only 10 or 15 mil, because then you're avoiding that thermal bridge.
Right. So it seems like there's quite a lot of potential to make some mistakes throughout this. Lots of details of joining insulations, joining components of a building. How are people able to sort of overcome these potentially difficult interactions of materials?
Well, as I mentioned, there are some online guidance. I mean, the solid wall insulation, Bristolians guide to solid wall insulation is accessible across the country. So if you don't live in Bristol, you can still access it. That's a very practical one. It looks at all the period properties types across the city, from Georgian through to Victorian and then into the 20th century, with some good detailing. So that would be a good start.
Right.
I would, of course, say that the Green Register courses are a way to learn about this. And again, we may be talking about this later, but a lot of our courses up until COVID have been very practical. So we'd actually get physical demonstrations of how to detail around windows, difficult junctions, getting air tightness right, using air tightness tapes and so on, using full-size mock-ups and so on.
Yeah.
And other courses are available.
Excellent. Yes, well, let's talk more about that in a bit. We've touched on insulation, or we've sort of dealt with that. We know how we're going to insulate our home. You've mentioned there air tightness. Can you tell me what the importance of air tightness is and how maybe we'll achieve it?
Yeah, so air tightness is basically trying to remove drafts.
Okay.
That's what it is. Either direct drafts through poorly installed windows where there might be a gap between the window frame and the wall, but also to do with the fabric, the actual walls, floors and roofs of buildings.
Yeah.
And any time you have a draft, you're making your heating work harder. And since most of our heating is using fossil fuels, although that is changing, anytime you've got a poorly performing external envelope, walls, floors and roofs, you're making your heating system work harder. So the idea behind air tightness is to try and minimise the gaps, the drafts, whilst maintaining fresh indoor air quality. So there's a difference between unintended drafts or infiltration of air and ventilation. So as you tighten up a building and remove those drafts so that your heating system isn't working so hard and you're not using so many fossil fuels and producing CO2 and so on, you then have to make sure that your quality of air inside is good for human habitation.
Yeah. And how are you achieving that?
So it's mainly around junctions. Mm-hmm. So anywhere there's a junction between a wall and a floor, or a window and a wall, or a door and a wall, any junctions are potential routes for cold air to come in and provide that unwanted cold air. So it's good practice. It's actually not that difficult to do, and as a builder, you'll know that if you're just a good, competent builder, you probably will get a reasonably airtight building. Mm-hmm. So it's not rocket science, it's good practice. But I think where the gap in knowledge is, it's a bit like the insulation, is that people think, well, it's just a couple of mil between, the mineral wool and the timber frame. What difference is that going to make? But you get a prism effect. The small gaps attract a disproportionate amount of heat loss and moisture.
Right.
So trying to get those gaps to be minimised is what air tightness is all about. And as I say, it's not difficult, but I think part of the problem is people don't understand the importance of these small gaps. They see them and they think they're inconsequential, and they're absolutely not.
Right. Okay. And how are we measuring the airtightness of a building?
So something called a blower door test, which is a pretty straightforward way of measuring how leaky your building is. There's a number of people that will do it, and it basically you employ somebody that's got the kit, and the kit usually is a panel that's a door size with adjustable size to fit snugly into a door. It's made up of fabric, and in that fabric there's a fan. And you insert the panel in the door, you close all the windows and the vents and everything in the building, and then you turn the fan on. Mm-hmm. And the measurement of air tightness is the number of cubic meters of air changed per hour at a certain pressure differential.
Okay.
So it's meters per cubic meters per square meter at 50 pascals. And what the fan does is it pushes air into the building, and it measures how fast it has to do that. So if you imagine an extreme version where you forget to shut a window, you start the blower door test, and that fan is just constantly trying to get that 50 pascals difference between inside and outside, and it can never get there. So it registers it as an incredibly leaky building. In contrast, if you've got a very airtight building, like a passive house building, which is a German standard, and they have very low air tightness standards, you turn the fan on, you get up to the 50 pascals difference, and you really don't have to pump much more air in,
right? Because
it's so airtight, it's not leaking anywhere. Mm-hmm. And then you can do something called a depressurizing test, where you take the fan and you reverse it, and you suck the air out of the building. And what that helps to do is identify where the drafts are.
Okay.
So you can reverse the fan, you go inside the building, reverse the fan, turn it on, and then you use something called a smoke pencil, which is just like a little wand with smoke coming out of it, and you can go around the building. And because you're pulling air in from the outside, because the fan is reversed, as you hold the smoke pencil up against the places you reckon you're going to get the air tightness or the leakage, the smoke will move faster. So it's a visible way of identifying where those gaps are.
Sure. And then presumably you can fix those issues and seal up your building better.
Yeah. What often happens, unfortunately, is the building is finished with the internal boarding finishing. You do the air tightness testing, and when you've identified where the gap is, it might actually not be where the gap is.
Right.
So, say, for example, you've got a dot and dab plasterboard, and it looks like it's manifesting itself at the skirting. Mm-hmm. The gap might be actually the other side of the room, but it's travelling behind the dot and dab, and it's just coming out in the skirting. So the ideal situation, which doesn't often happen, is you have a 2-part air tightness test. You do one before the boarding is finished internally. Mm-hmm. Then you can literally see where the gap is and where the air's coming in. You do the remedial works, finish it off, do another test, and hopefully you're you're getting to your achieved level.
Right. And what sort of levels are, say, an unretrofitted building? What air tightness would you expect one of those to achieve? Obviously, depending on the period.
It does, and interestingly enough, some of the Tudor half-timbered buildings are quite good,
right? Because
they've used wet plaster, and wet plaster is a very good air tightness layer. Mm-hmm. So it's not necessarily that older buildings are going to be poorer, although it generally is. The building regs uses 10 cubic meters per square meter, 50 pascals, mm-hmm. Which is a very easy standard to achieve.
Yeah.
Passive house, which I've mentioned, is below 1. If you get lower than 3 air changes per hour, that's a very good air tightness level, but you'd have to introduce some kind of mechanical ventilation because that's too airtight to provide enough fresh air for people.
Okay. On one of your training sessions just last week, someone helped to visualize that. I forget whose talk it was, but they said that the 10 level, so the sort of the standard, the building standard, was a hole the size of an ATM machine. If you added up all the little cracks, that's how big the hole could be. And then a passive house standard was a hole the size of a credit card.
That's right. So that was a good illustration.
That was fantastic. Yeah.
Yeah. That was Niall Crossan from Ecological Building Systems. It's a very good way of demonstrating that.
Yes. I mean, that's an ATM is a huge, I mean, that is leaving a window open.
It pretty much is, yeah. And you will get some resistance from some people who feel, particularly in older buildings, that it's not how they were designed. They were designed to allow fresh air to come in and keep the building dry and to keep the internal air quality healthy. And it's true that they were, but if you can do it right, you will reduce your heating load and keep the indoor air quality to a good level.
So you mentioned there that if we get below 3 meters cubed or 3 air changes?
3 air changes per hour, yeah.
Okay.
Mm-hmm.
Then we have to add in ventilation. And what mm-hmm. form can that come in? Is ventilation not just getting rid of all of our heat and all the gains from sort of sealing up the building and insulating?
Yeah, so there's something called whole house heat recovery, MVHR, and that's the preferred method for new build, mm-hmm. Because what you're doing is building a very airtight house, and then you're wanting to introduce fresh air, but you're not wanting to take the valuable heat of the house and chuck it out when you're exhaling stale air. Mm-hmm. So the whole house heat recovery system, which sits somewhere in the attic, will indirectly exchange all the stale air's heat with the incoming air and temper it so it doesn't have to be heated very much. And I understand that you can recover about 90% of the heat from the exhaled air.
Excellent.
I think that most people feel that it's a bit sort of sledgehammer to crack a nut, whole house heat recovery for retrofit. Mm-hmm. So you can have something called demand control ventilation, which is a much simpler system. It still provides fresh air, but it doesn't do a lot of heat recovery, and it only kicks in when the humidistat determines that a certain combination of internal environment to do with humidity and so on is present. Mm-hmm. So that's a less complicated way of doing it. You can also employ something called passive stack, where the natural system is to warm, moist air rises up in the building, and you have cooler inlets of cooler air rising up, and there's no mechanical parts there. But you have to have a building that can be designed that way, where the intake and the extract vents are positioned properly, and you've got the right wind conditions and mm-hmm. that sort of thing. So
one of the resistances I get sort of presented to me quite a lot when we're talking certainly about passive house and the air tightness that you're achieving there is that people are a little resistant to living in what they perceive to be a bubble, maybe a balloon. Well, you've retrofitted your house. How does it feel to live in one of these tighter buildings?
Well, despite numerous air tightness tests and me stuffing lots of gaps around the house on an ongoing basis, we can't get below 8.
Okay, really?
That is with a lot of effort. It's an existing building. It's on the top of a hill. We get a lot of wind. I've just had to accept the fact we're not going to get, I've done it 3 times and we can't get below 8.
Yeah.
Having said that, I do employ a kind of purge system in the winter. So most days I'll open 2 windows in opposite parts of the house for a few minutes just to sort of flush through the pollutants and the stale air.
Right.
And it's a short enough time in the winter not to really cool the actual fabric down. It just replaces the air. But with the more robust air tightness buildings like Passive House, I've not experienced it, but I've not heard anybody ever say anything other than positive, because it's a managed air management system, and it is providing good quality fresh air to the inhabitants. Of course, in the summer you can turn it off if you want to, and you can have the windows open. Yeah, it's not an enforced thing, but I've anecdotally not heard any bad experiences of that. I think there is sort of a cultural thing about us. We, as a nation, we sort of throw our windows open and get some fresh air and sleep with the windows open at night, which is what we do. And you like to hear the birds singing and, see what your kids are doing in the garden and so on. So there is some resistance, which I understand about that.
But the benefits for how much money you're spending, for how much of the Earth's resources you're using, should be a good enough incentive.
Yeah, I think it is. And I think the other incentive for individual householders is the quality of the air and the healthiness of the internal environment. We do spend 80 or 90% of our time indoors. Clearly at the moment that's a lot higher, but generally speaking, most of us spent quite a lot of time inside, and the inside air quality can be more polluting than the outside air quality.
Right.
So with something like Passive House, you're really providing good quality air, and particularly with kids with asthma or other people with health issues, that can be a real game changer for them.
So what sort of cost are, again, I'm going to ask you about an average house that doesn't exist. But if we were to retrofit, say, a sort of 2-bedroom family house, semi-detached, have you got an idea of what sort of cost that might be to retrofit, and then what sort of savings that would in turn give?
I'm probably not going to be able to give exact figures on that.
Okay.
But if we look at the measures first, simply doing things like replacing your boiler, for example. If you've got a very old boiler, it's going to be running very inefficiently. So replacing a boiler might be £3,000 or £4,000, but you'll be using the heat that's coming in much more efficiently. So your bills should go down, as well as having an impact on using fossil fuels. You can do a lot of low cost things like draft proofing your windows, either as a DIY project if you're confident in that, putting secondary glazing up if you can't put double glazing in, maybe replacing windows, depending on the window style, might be £800 or £1,000 per window. That might make a significant difference to your heat loss, but also to your comfort levels.
Right.
And that's something that Passive House focuses on a lot. It's not just about energy, it's about comfort in the house. If you're going to do some wall insulation, that will be several £1,000s, depending on what measure you employ. Loft insulation is just a few £100s. Then there's other kind of heating controls you consider. If you don't have a thermostat, obviously that's a plus. So your heating's not going on when you don't need it. That's quite a small investment of money. You can go to more complicated things like thermostatic radiator valves and weather compensators, other accessories that will make your heating system work more efficiently. What other things could you do? Yeah, I think there's sort of what people refer to as the low-hanging fruit, like the draft proofing and heating controls, and windows where you'd start with, and they're low cost but high carbon saving.
So On your Green Register courses, how many builders are you getting that want to learn how to do these details?
That's an extremely good question. And as I mentioned earlier, the intention of the Green Register was to get across the board delegate attendance so that we'd get builders, contractors, architects, engineers and so on together. We have spent 20 years, nearly 20 years, trying to encourage builders onto our courses with very limited success. We've got a small number of builders on the Green Register, and they're the sort of pioneer builders. They're the people like you who've been doing it for some time, who understand the issues, who have got clients who want to build like this. But very frustratingly for me, we have had very little uptake from builders until about 18 months ago. Mm-hmm. And then we were approached by Malcolm McMahon, who was until recently the director of Greenheart Sustainable Construction. And they're one of the most sustainable builders I know, mm-hmm. who have had decades of experience and came to the Green Register saying, we've now got quite a lot of experience in sustainable building. Can we share this with other people and try and get more builders onto the Green Register course, which of course we were very, very keen on doing. We started working with Malcolm, mm-hmm. and then just out of coincidence, BASE, which is Business, Enterprise and Industrial Strategy Government Department, then sent out a request for bids to work on the retrofit problem. Mm-hmm. And that is that not a lot of retrofit is done very sustainably. So we had already started this conversation with Greenheart Sustainable Construction. The bid came along, and Centre for Sustainable Energy, which is CSE in Bristol, as an energy advice charity, approached us and said, would you like to come in on the bid with us? Which we did. Mm-hmm. And we won the bid in November 2018. And the premise of our application was that CSE, who are, as I say, are an energy advice charity, get lots of phone calls from homeowners saying, I really want to improve my building, my house. I can't find the builders. Mm-hmm. So there was a pent-up demand, and they could provide the demand, CSE could provide the demand, and the Green Register was tasked with providing the supply. So in other words, training the builders to be able to satisfy the demand of CSE and other clients wanting to do this. And so when we won the bid, we started working on this project called Future Proof, mm-hmm. and it's a kind of arm of the Green Register, and we worked with CSE, and its primary function is to train builders in sustainable retrofit. And we went into it with our eyes open, having had 19 years experience of trying to get builders onto our course, knowing the barriers that there were. We had some networking sessions and some breakfast meetings with the kind of core pioneer builders in Bristol and the Southwest. I should mention that the Future Proof is currently a West of England initiative. That's mm-hmm. the way BASE wanted it to run. And we identified all the barriers. So the barriers are things like builders are really busy. They don't need to change their building practices. Building control doesn't pick up on stuff that might not be compliant with building regs, or it gets through after the inspection. Clients don't want to pay for it. Builders don't want to take time off. They're not paid to go and do training. All these barriers. And we've tried to solve that with Future Proof. Mm-hmm. And Future Proof is really gaining traction now. It's been a very steep journey for us, but we now have dozens of builders like you on our training courses, and we're absolutely delighted that it's gaining traction.
So how are some of the ways that you've solved those issues that were brought up in the first?
Well, probably the core one is that we pay builders to attend, and that seems to have unlocked everything, surprisingly. We haven't got a huge amount of money from BASE, but we wanted to remove the barrier of it being a financial burden on the builder. Mm-hmm. So we are paying builders to attend our training. We are trying to make it very much a blended learning experience. So we don't just do site visits, we'll do the backup theory that goes with it. Just a good example of that would be we had a couple of hours on lime, different uses of lime in buildings. Mm-hmm. Then the trainer brought some lime in, showed how to apply it. And before COVID came along, we were lining up a site visit to show the builders how to apply lime in practice. So it's a very practically focused set of training. We've tried to time it so that it's not right in the middle of the day. So it's either early morning or after most builders have finished work. Mm-hmm. They're short and sharp, so they're not, huge, long seminars, hours and hours long. And we're trying very hard to connect builders together. So we have social events and so on, so that builders feel that it's worth doing and that there's other people out there doing it. We've got a WhatsApp group so people can share ideas and swap different thoughts about sustainable building. Excellent.
But there's a lot of builders out there who maybe aren't currently working to create sustainable buildings or aren't focused on the details. How are you working to influence them and maybe help to change their sort of mindset or practices?
Yeah, I think we're realistic that we're not going to reach everybody. Mm-hmm. So if you imagine a sort of concentric circle, in the middle of there, the pioneers, which are the builders that we started working with, who, like you, they're already on board, they understand the issues, they're already practicing what we're trying to teach them. The next concentric circle out is the early adopters. Mm-hmm. So those are the builders that would like to do it if the budget's there and the client's keen and so on. And that's the group that we're concentrating on at the moment. The next level out is the people who might be interested. And then there's the general builders who will never get to, and we're not trying to either. This is quite a small project at the moment. But one of the things that we have developed is what's called Toolbox Talks. So once our builders have completed a certain number of training sessions through Futureproof, they become what we call FABs, Futureproof Associated Builders, FABs. And they're then offered up to other builders to provide toolbox talks. So this is peer-to-peer learning. Mm-hmm. So it might be somebody on that second concentric circle is interested, but just really doesn't get air tightness. They'll call us up. A FAB will then arrange to go out on site, have a look at it, train them on the basics of air tightness. And what we've said is we'll give 2 free toolbox talks to any recipient who wants. If they want more of that, we encourage them to come in and become FABs, become Futureproof Associated Builders. And the idea behind that is the pool of trained builders gets bigger and bigger.
Yeah.
So we spread the word through Toolbox Talks, but we're also trying to recruit more builders to come in.
Great. That's a fantastic, obviously I know all about it, but I think it's a fantastic way of passing on that knowledge and getting it out there.
It really is, and the feedback we've had has been fantastic with the few Toolbox Talks we were able to do before COVID.
Yeah. Excellent. Thinking about particularly Bristol, which is where I'm living. They've said that we're going to be net zero by 2030. What does that mean for existing buildings, residential buildings, in terms of their energy efficiency?
Yeah, well, it's a real big ask, isn't it, to be carbon neutral in less than 10 years. I attended an event at the beginning of the year held at We the Curious in Bristol, and the mayor, Marvin Rees, was there, and he was trying to sort of convey some of the measures that they were looking to implement to try and achieve this. I don't know what's going to happen with COVID. It might actually have a good result, but being that construction and existing buildings are such a large part of that, I didn't get the sense that Bristol City Council was putting that at the top of their list, but we are trying to work with them to encourage people to engage future-proof builders, because then the builders will be able to do the the retrofit work that actually will reduce carbon. I think we're in early days yet, and COVID has thrown everything up, but I think we need more conversations with Bristol City Council because, Marvin Rees's priorities are understandable, but it's housing and jobs. And the built environment isn't top of his list. But actually, in order to get to that net zero carbon, we have to do everything all at once. We have to do the street lights, we have to do the council fleets, we have to do the buildings, we have to do industry. Everything has to be done. So I think it's an emerging set of policies, and we want to be able to work with the council to help them achieve that.
It seems like an enormous task. If, say, the aim would be to retrofit all the buildings in Bristol, that's a lot of buildings, and less than 10 years isn't a lot of time to get that all done, especially to a high standard, which isn't going to repeat the issues that you talked about in Preston. It seems to me like I can't picture how it could happen at the moment. I hope that future-proof is, it's definitely helping towards that.
We hope so. Yeah, we hope so. We want to recruit more builders so that there'll be more builds available as and when the council says, right, we need good quality retrofit. Where are the people who can do it? We need more builders. As I said, we are getting a lot more recruitment, but we need a lot more.
So you said that it's currently in the southwest?
West of England, yeah.
West of England. Is there a plan to roll that out and make it nationwide?
Well, interestingly, that's a silver lining that COVID has presented to us. Obviously, we can't do any face-to-face learning anymore for the time being anyway. And we've had to convert all our courses to online courses, including our future-proof courses, and have been absolutely delighted with the response, particularly from builders who, we are generally trying to focus on face-to-face practical learning. But builders who've attended courses since the virus created lockdown have been extremely positive about the courses. And what's materialised is that once you make a training session online, it's not geographically limited. So Bays has 6 pilots around the country. We are one of them. We are limited to the west of England, which is the counties that used to be Avon. But all of a sudden, we have the potential for being able to bring our training nationwide. And at the moment, we're working with a not-for-profit called Carbon Co-op in Manchester, who are kind of a hybrid of the Green Register and CSE in that they work with householders and builders. And we're going to run a pilot with them to work out how we can do this sort of blended learning where we provide the online content and Carbon Co-op do the on-site sort of face-to-face training, site visits and so on, which will be in the future once we're outside of lockdown. But, despite the absolute tragedy that COVID is, the silver lining is that we could actually expand this project nationwide. And of course, other councils are signing up to zero carbon too. So they need builders who know what they're doing to address the existing building stock. So we're very hopeful on that.
Excellent. Well, I think, what you're doing is fantastic.
Thanks, Jeffrey.
Very pleased to be a very small part of it.
Well, you're a very welcome part of it.
Was there anything else that you wanted to talk about in particular? Anything that...
I would say if anybody's listening who is a builder, who is interested in becoming a future-proof builder, to look on our website, either the Green Register or futureproof.net.uk, or it might be .uk.net. Sorry, I can't remember that.
I'll put a link in the...
Thank you. Also, if you're a client or you're a self-builder and you want some help from a builder who knows what they're doing, because obviously you need the builder and the client to be on board with this. And recent experience has found that most builders will say, well, I'll just do what the client wants. And we need more clients who want the builder to build sustainably.
Yeah.
So put them in touch with us as well, or in touch with CSE, Centre for Sustainable Energy.
Excellent. All right. Well, I'll put all those links out on the show notes, and thank you so much, Lucy.
Thanks very much for letting us talk. Thanks, Jeffrey.
So thank you so much to Lucy for recording that conversation, taking the time. There'll be a list of links in the show notes to this podcast for all of the things we've talked about. Want to say a big thank you again to Mike Hill for giving us our music, and to you, the listeners. Thank you very much for listening for this first year. I hope you've enjoyed it. I've certainly enjoyed reading your comments and hearing your suggestions. So especially thank you to Lee John Phillips. He has created a wonderful, really great logo. I spent a long time looking back over the year's work and seeing how it developed and how it changed. And it's maybe taking on a slightly different route than I maybe originally intended. I was looking out at other podcasts, and there's lots that are to do with building science and a very, very kind of clinical, I guess. And I like that actually that building sustainability is got more of a focus on craft and tradition and people. I feel like that's it's maybe a slightly unintended consequence. I'd been thinking about redesigning the logo, and I was thinking about using old tools to represent the craft and the heritage and the building. I thought about it and then realised that Lee was a far, far better artist, designer, and that I should just ask him. Luckily, he had a gap in his schedule and said he would. I think he's boiled down the essence of the craft, the heritage, the nature and the people into 3 perfect tools. So yeah, many thanks. Once again, I hope you've enjoyed listening. If you have got suggestions for who might be a good podcast guest, then please drop me a line or get them to send me an email. And following straight on from this episode, there's 2 more. So I hope you're staying safe and healthy, and remember, stay home.